The base is a polygon. That's how it's named, by the base. And the lateral faces are triangles. I abbreviated there, triangles, with a common vertex. What do you think would make a regular pyramid? If the base polygon is a regular polygon, okay? And if this would be perpendicular, as it is, that's perpendicular. So that makes a regular polygon. Most of what you work with will be regular polygons in this chapter. So we could just write regular polygon base. Let's draw a picture down here. This is how I draw a pyramid. Like, for example, this pyramid. If it has a square base, I kind of just draw it like a parallelogram. Put a point up here. And then connect it. Sort of like that. We have some parts of this triangle that you should label. I probably should have done it bigger, but that's okay. From the common vertex down the center is considered the height. That's the height. Or H. Then, from the common vertex down the face is also a height of a triangle, right? Well, that we can't call that height as well. We call that slant height, which kind of makes sense because it's on a slant. Let's see if I can make that a little bigger for you. So on this right here, if you go up the center, it's the height. If you look at this height right here of this triangle, that's called the slant height. And it's represented with a different letter. It's represented with an L, a cursive L. A cursive L. Okay, pardon me? Yeah, you could look at it like that. Yeah. All right, the surface area of a regular pyramid is this, S equals B. Why is it not 2B? There's only one base. Right, and you only have to find the one area, plus 1/2 capital P, which stands for what? Perimeter of the base, times L, which stands for what? Slant height. Sometimes, I'm going to tell you right now, and students don't usually like this, sometimes you have to find the slant height by using the height and realizing that this inside here, if you were to cut a piece out of that, is a right triangle. So you sometimes have to realize that L and H, you might have to use the Pythagorean theorem to find the slant height at times. Okay?
Well, then what would be like the bottom?
It would be half of this distance. It's a good question. It would be half of the side length of the base. Okay? Let's draw a cone. Sort of like an oval kind of shape. Put a point up on top. And then just connect. Sort of a cone there. Cones are cool? Okay, same thing here. Down the center to this, down the vertex to the center of the circle is the height. And then the side from here to here is also called slant height. That's also L. And again, you can also cut a right triangle out of there if you had to use Pythagorean theorem and consider it. Okay? All right, the surface area here is almost the same. S equals B plus 1/2 capital C. What's capital C? Yep, times L. So it's really the same. You're just changing P to C. Sorry. It's really the same. You're just changing P to C.
I know, but I'm.
Lateral surface in a cone is really, in a cone, is all but the base. Does that make sense? The lateral surface is all but the base area. Okay, let's practice these two formulas. You might want to rewrite this circular one. You know, you might see it this way. How do you find the area of a circle? Pi r squared, right? Plus 1/2 circumference times L. Sometimes you'll see it that way. I don't care which way you write it.
Yeah.
What?
Oh.
Lots of talking today. All right, here we go. Let's dive in and do it. A regular square pyramid has a height of 12 feet and a base edge length of 10 feet. Now be careful. It's not always find all the surface area. Sometimes it's part of it. It says find the area of each lateral face of the pyramid. So I only need to find the area of one of the triangles, right? That's all I need to do. So let's look and see what they gave us. Here they gave us 10. I have the base of the triangle. So if I draw the picture, let's draw the whole picture here. This is one of them. That's 10 feet, right? Did they give me the slant height?
No.
No, they didn't. Yeah, I need L. Do I need L? No, I don't know if I need L. Yeah, I do. I need to know this, right? I need to know the height of the triangle. And so what I'm going to do is I'm going to take out this triangle right here. Take out that triangle. The bottom part is 5. Oh, yeah, I need to zoom back in. Sorry. So I'm doing this triangle right now. I know that this is 12, right? Oh, okay. And then I can use the Pythagorean theorem. It's a special right triangle. Does anybody know what it is? It's 13. If you know it, easy peasy, you know this is 13. If you don't know it, use the Pythagorean theorem. 5, 12, 13 is a special right triangle. Now, what this is, ladies and gentlemen, what this is the slant height. That's L. That's this piece right here. Right? This piece right here. If I'm looking at this triangle, I only need the area of that triangle. That's what they're asking me for. They're just asking me for the area of that triangle, one of the lateral faces. So here it is. I drew it. It's right here. I know the base is 10, and I know the slant height that I just found is the height of my triangle. The slant height that I just found is the height of that triangle. So now I can just use the area of a triangle is equal to 1/2 base times height. Area of a triangle is equal to 1/2 the base of one of my faces, which is 10, and the height of one of my faces, which is 13. So that's equal to 65. There's another way to do it. And I won't talk you through it all the way, but let's think about the formula they gave us, 1/2 P times L. Okay, let's think about the parts of this. This is what?
Base.
Right, this is the area of the base, right? Plus 1/2 the perimeter times L. So this is the area of all the faces, isn't it?
Yeah.
So I could just find this piece and divide it by 4. Right? So I could just find that part of the formula and divide it by 4. So there's another way to do it. It might be easier than this. I don't know. It's up to you. Still have to find the slant height no matter what. So that's another way to look at it. Okay. Find the surface area of a regular octagonal pyramid if the slant height is 18 feet. You're always happy when they give you the slant height. It usually means you don't have to use the Pythagorean theorem. And the apothem of the base is 15.7 feet, and the sides of the base are 13 feet. Okay, if I have to find the surface area, I'm writing this down. I'm going to plug in what I know. I know that the base is a regular pyramid. So to find the area of a regular pyramid, I do 1/2 times A times P plus 1/2 times the perimeter times L. Now I'm going to plug in what I know. They gave me pretty much everything I need. So the base is 1/2 times my apothem, which is 15.7, times my perimeter, which is, how long is one of my side lengths? 13, and how many sides do I have? 8. So this says 1/2 times 15.7 times 13 times 8. That's the area of my base. That's my capital B right there. Plus 1/2. The perimeter, again, is going to be 13 times 8 times the slant height, which they gave me, which is what? 18. There's all my numbers. And when you do that, you get approximately 1752.4 feet squared. Almost done. What is the surface area of a right cone? S equals capital B plus 1/2 C times L. Well, let's see what we got in the picture here. We can find the area of the base, no problem. We can find the circumference because we have the radius. We don't know L. We need L. But that's easy enough, right?
Yeah.
Yeah, it's just this right triangle here. If I cut this piece out, it's 10, 24. Use the Pythagorean theorem. This might even be a special right triangle. I don't know if it is or not. I had to do the work. L is equal to 26. So L equals 26. Plug it in. Area of the base, which is a circle, is pi times 10 squared plus 1/2 2 pi r times 26. And when you do that, you get 1130.97 centimeters squared. Okay, a carpenter uses a weight in the shape of a right cone to identify vertical lines. The cone has a radius of 6.5 centimeters or millimeters, and a height of 13 millimeters. Find the approximate lateral area of the weight. So we don't need the base. So if I write this thing down, I don't need that. If I need the lateral area, I don't need the area of the base. Okay, so I still need to find L, don't I? I'll just give it to you. If I cut this triangle out, it's 6.5 and 13. Use the Pythagorean theorem, and you would get for L 14.53. 14.53. Plug it in. Surface area equals 2 times pi times the radius, that's the C part, that's C, times L.
What the half?
Oh, yeah.
Right there.
And there's half there. Thank you. Easy to make mistakes. So basically the half and the 2 cancel each other out as well. And you just do pi times 6.5 times 14.53. I didn't even finish this one. What'd you get?
296.
Let's do this. Yeah. Millimeters squared. Not my favorite chapter, I'll be honest with you, but
But it's the last one.
it is the last one.